I think one of the best features about the CDMI is that it's a partnership between industries and academic institutions. And so the pushing and pulling study that we're doing is an example of one of those in which we want to better understand how those type of activities impact the body and how the likelihood for damage to the back can be minimized or eliminated based upon the research that we're doing here to really prevent the likelihood that someone develops a soft tissue or musculoskeletal disorder. When it comes to cumulative damage in the spine, we don't have any feedback mechanism that tells us when we're doing that damage. And that's what the beauty is of this spine model that we're using, is it's able to say whether or not that activity is causing some damage at that point in time.
We have some really unique tools here in the Spine Research Institute to measure a whole bunch of different types of information about a person as they're moving, as they're doing tasks. We have custom-built force transducers that are measuring the forces in a whole bunch of different dimensions, so 6 dimensions actually, as subjects are pushing or pulling on the load cell itself. And ultimately, the goal of this project is to relate, a more rudimentary tool, which is a single-axis force gauge. How do those forces compare to that really complex hand transducer that we have here in the lab? As most practitioners will use a single-axis force gauge, a lot of practitioners have seen that the use of that force gauge can be very, very imprecise. So you might take 10 measurements and get a wide array of force measurements throughout those 10. Or they can be very inaccurate in the sense that depending on the acceleration that you choose to move that cart with, one person might get 40 pounds, whereas another person might get 65 pounds. And the ultimate goal of this is to create the best practice that will relate the pushing and pulling forces that are being recorded by the gauge to what workers are actually exerting onto the cart in industry. This project's really interesting in the sense that when you're testing the pushing and pulling forces with a hand transducer, the biomechanics and the way that subjects push or pull or interact with the cart really does change, as opposed to how a person might just push or pull on a cart in a regular environment. So one of the benefits of this project will be to relate this kind of the forces that you get out from this more rudimentary or more contrived pushing and pulling procedure to something that would be more accurately reflecting what would be happening in the workplace on a day-to-day basis.